Imagine taking Mount Everest and dropping it upside down into the Pacific Ocean. The summit disappears beneath the waves, with a full mile of water still remaining between the mountain's peak and the bottom of the trench. Descending into this abyss means leaving the known world. Past the sunlight zone, the vibrant blue fades to an eerie twilight, and then inevitably to pitch black. The water temperature drops to near freezing. This diagram illustrates the weight at the Challenger Deep. Down here, hydrostatic pressure is over 1,000 times greater than at sea level. That is the equivalent of having 50 jumbo jets stacked directly on top of your body. This environment actively rejects human presence. For decades, the sheer hostility of this crushing darkness led scientific consensus to assume that nothing could possibly survive here. Reaching the bottom required a total rethinking of naval architecture. Engineers had to develop specialized titanium spheres designed specifically to keep the ocean from crushing submersibles like empty aluminum cans. In 1960, Jacques Piccard and Walsh used the Trieste, a massive, heavily reinforced vessel, to leave the known world behind and touch bottom. Modern explorers, including filmmaker James Cameron, have continued pushing these engineering limits, using updated technology to map the shadows and capture high-definition footage. These submersibles represent a physical defiance of nature. To cross into this alien world, humans must seal themselves in thick metal to survive the physics of the descent. But the reality discovered at the bottom is far more fascinating than the expected wasteland. Cameras revealed a ghostly, thriving ecosystem of extreme survivors. This is the Mariana snailfish. It is a translucent creature that spends its life under weight heavy enough to crush a military submarine. This diagram shows its evolutionary adaptation. The snailfish developed a gelatinous body and flexible skull, allowing internal structures to equalize immense pressure. By foregoing rigid, hollow bones, it ensures no air pockets implode under the abyssal weight. Biology solved a brutal physics problem through adaptation, achieving naturally what humans required titanium engineering to mimic. The silt of the trench is home to bizarre scavenging amphipods. Without sunlight to support a traditional food chain, these creatures rely on a different energy source. They feed on marine snow, the decaying organic debris that continuously drifts down from the upper ocean like falling ash. This food web functions without the sun. It is driven instead by chemical-rich vents fracturing the ocean floor, sustaining life in total darkness. This is an ecosystem adapted to total isolation, existing independently of the world above. When explorer Victor Vescovo piloted his submersible to record-breaking depths, he expected to document a pristine, untouched landscape. Instead, 11 kilometers down in the silt, his lights illuminated a plastic shopping bag and candy wrappers. This diagram tracks the descent. Much like natural marine snow, human pollution sinks passively from the surface, falling past the sunlight zone and settling directly into the trench. This unnatural debris interrupts the isolated biological zone, integrating with the organisms that live in the silt. This single artifact proves that the most remote place on Earth has been reached and compromised by human activity. Subsequent scientific studies found that synthetic microplastics are now woven directly into the digestive tracts of bottom-dwelling crustaceans. These organisms evolved to withstand immense physical pressure, but they possess no defense against the synthetic pollution introduced from the surface. The Mariana Trench is no longer a distant geographical wonder. It has become an archive of our chemical and industrial footprints. We have mapped the stars and touched the deepest abyss, but the trench stands as a silent reminder. There is no part of this world so deep or so distant that it is immune to the choices we make on the surface.